What are these? Stick around to find out. My name is Curtis Matthews, and this is my application video for the available position at Tetrahedra Consulting for the course ENGG4500. An engineer's solution to a presented problem almost always requires a complex response with some form of creative input. In this video, I've opted to use an example to explain the core processes that can be used to form a solution to a said problem in my understanding. In this triangle, there is a goal in the center. The real-life example I'm using is designing an Olympics-grade aquatic center, which was done in Beijing. We can break this problem down into three key questions. Why are we designing the solution? For what purposes? What relevant information can we use? And how? How can we apply this information to find our own solution? So let's begin with why. Another way to say why is, why are we designing the solutions and what are the requirements? To solve this, we're going to use conceptualization and abstraction. So let's conceptualize about emotional, environmental, and physical requirements. We may need to be sustainable, renewable, and have a minimal footprint. We may need visual appeal, be functional with our surroundings, and it may need to have longevity, stability, durability, and cost effectiveness. So now that we've defined these, maybe we can define a requirement for each one of these. So emotionally, it needs to be attractive and consistent with its surroundings. Physically, it needs to be structurally integral with minimal cost and maximum sustainability. And environmentally, it must have a minimal environmental impact by minimizing the energy consumption. Okay. Now we can move on to what. What do we know that has the qualities laid out in the requirements? For this, we can use biomimicry. So laying this one down, what do we know that has a minimal environmental impact? Plants have been known to absorb light and turn them into energy for billions of years, so that meets the requirement. What do we know that is visually appealing and relatively consistent? A forest is consistent and beautiful in terms of nature, but each element has its individual interest. And what do we know that is structurally integral in design? Bubbles may not be your first thought, but they are light, low density, and can form relatively large structures when combined. So that is what. So now we know these, we can move on to how. So how can we apply this to our design? For this, we're going to use evaluation and emergence. The bubble's natural structure was mimicked with ETFE composite to form a more than structural integral building with the added advantage of extra insulation. Using the consistency of the forest, the natural look of the building next to the natural look of the already existing bird nest stadium kept it consistent and visually appealing. And finally, the structure already mimicked plant cells, which meant that more light was getting in, therefore saving on energy, and it also captured 20% of solar energy, which could be used for heating pools. When we take this in, we can see that all these aspects lead to the final design of the goal. These concepts, interconnected as they are here, form a complex solution to this design problem. This design was done by Australians in Sydney and used in the actual Beijing Olympics.